Hello everyone, welcome back to the channel. In this video, we'll understand the concepts behind Java programming questions one by one. Instead of just selecting an answer, we'll look at why the correct option is right and why the others are not. Let's begin with Question 1. Question 1 says, consider the following Java program. The program defines a class named NPTEL with the main method, which is the entry point of every Java application. Inside the main method, we have the statement system, .out.println open, parenthesis quote, hello world, quote close parenthesis semicolon. Let's understand what this statement does. System.out.println open parenthesis. Close parenthesis is a Java method used to print text to the console. Whatever is written inside the double quotation marks is displayed exactly as it is. In this case, the text inside the quotation marks is hello, comma, space, world, exclamation mark. Now let's look at the options. Option A says, hello world. This exactly matches the text written inside the program. Option B says, hello world. This is incorrect because it removes the comma and the space. Option C says, compilation error. This is not correct because the program follows the correct Java syntax. Option D says, runtime error. This is also incorrect because there is no statement in the program that would cause a runtime exception. Therefore, the correct answer is Option A, hello world. Let's select Option A. Now let's move on to Question 2. The question asks, a Java file with the extension .class contains what? To answer this, we need to understand the Java compilation process. When a programmer writes Java code, it is saved in a file with the .java extension. This source code cannot be executed directly by the computer. The Java compiler, also known as javac, compiles the .java file and generates a .class file. This .class file contains Java bytecode. Bytecode is an intermediate code that is not specific to any one operating system. The Java Virtual Machine, or JVM, reads this bytecode and executes it on different platforms such as Windows, Linux, or Mac OS. This is why Java is known as a platform-independent programming language. Now, let's evaluate the options. Option A says Java source code. This is incorrect because source code is stored in a .java file. Option B says HTML tags. This is unrelated to Java class files, so it is incorrect. Option C says Java bytecode. This is correct because the Java compiler generates bytecode and stores it in the .class file. Option D says a program file written in Java programming language. This describes a .java source file, not a compiled .class file. Therefore, the correct answer is Option C, Java bytecode. Let's select Option C. Now let's move on to Question 3. The question asks, which of the following is not an object-oriented programming paradigm? To answer this question, let's first understand the main features of object-oriented programming, also known as OOP. Object-oriented programming is a programming approach that organizes software around objects. The four core principles of OOP are encapsulation, inheritance, polymorphism, and abstraction. These principles help make programs more modular, reusable, and easier to maintain. Now, let's evaluate each option. Option A is encapsulation. Encapsulation means combining data and the methods that operate on that data into a single unit called a class, while restricting direct access to internal details. This is one of the core principles of OOP, so this option is not correct. Option B is inheritance. Inheritance allows one class to acquire the properties and methods of another class. It promotes code reuse and is also a fundamental feature of object-oriented programming. Option C is polymorphism. Polymorphism means many forms. It allows the same method or interface to behave differently, depending on the object. This is another important OOP concept. Option D is dynamic memory allocation. Dynamic memory allocation is a memory management technique used in many programming languages. It is not one of the core principles or paradigms of object-oriented programming. Therefore, the correct answer is option D, dynamic memory allocation. Let's select option D. Now, let's move on to question 4. The question asks, what is the correct sequence of steps to execute a Java program? To answer this question, let's first understand the Java program execution process. Whenever we create a Java program, the first step is to write or edit the source code in a file with the .java extension. Once the coding is complete, the program must be compiled using the Java compiler, also known as javac. During compilation, the compiler checks for syntax errors and converts the source code into Java bytecode, which is stored in a .class file. After successful compilation, the Java virtual machine, or JVM, executes the bytecode and produces the program's output. So, the correct sequence is edit arrow compile arrow run. Now, let's evaluate each option. Option A says run arrow edit arrow compile. This is incorrect because a program cannot be executed before it is written and compiled. Option B says edit arrow run arrow compile. This is also incorrect because the program must be compiled before it can run. Option C says compile arrow edit arrow run. This is incorrect because editing must happen before compilation. Option D says edit arrow, compile arrow run. This follows the correct order of writing the code, compiling it into bytecode, and finally executing it using the Java virtual machine. Therefore, the correct answer is option D, edit arrow compile arrow run. Let's select option D. Now let's move on to question 5. The question asks, which program is used to compile Java source code into bytecode? To answer this question, let's first understand the role of the Java compiler. When we write a Java program, it is saved as a file with the .java extension. This file contains the source code written by the programmer. Before the program can be executed, it must be compiled. The Java compiler is called javac. The javac command reads the .java source file, checks it for syntax errors, and if no errors are found, converts the source code into Java bytecode. This bytecode is stored in a file with the .class extension. Later, the Java virtual machine, or JVM, reads the .class file and executes the program. Now, let's evaluate each option. Option A is javac. This is incorrect because javac is a class file disassembler used to inspect bytecode. It does not compile Java programs. Option B is javac. This is correct because javac is the Java compiler that converts source code into Java bytecode. Option C is Java. This command is used to run a compiled Java program using the JVM. It does not compile the source code. Option D is javad. This is not a standard Java compiler command, so it is incorrect. Therefore, the correct answer is option B, javac. Let's select option B. Now, let's move on to question 6. The question asks, in Java, what is the role of the public static void main string args method? To answer this question, let's first understand what the main method is. Every standalone Java application starts its execution from the main method. When you run a Java program, the Java virtual machine, or JVM, looks for this method first. Once it finds the main method, it begins executing the program from there. Let's briefly understand each part of the method declaration. Public means the method can be accessed from anywhere. Static means the method belongs to the class itself, so the JVM can call it without creating an object. Void means the method does not return any value. Main is the predefined method name recognized by the JVM. String arg stores any command line arguments passed while running the program. Now, let's evaluate each option. Option A is initialization method. This is incorrect because the main method is not used for initializing objects. Option B is execution entry point. This is correct because the JVM always starts executing a Java application from the main method. Option C is constructor. This is incorrect because constructors are special methods used to initialize objects and have the same name as the class. Option D is destructor. This is also incorrect because Java does not have destructors like some other programming languages. Therefore, the correct answer is option B, execution entry point. Let's select option B. Now, let's move on to question 7. The question asks, which of the following is not a feature of Java? To answer this question, let's first understand some of the key features of the Java programming language. Java is designed to be platform independent, which means a Java program can run on different operating systems using the Java Virtual Machine, or JVM. It is also an object-oriented programming language, supporting concepts such as encapsulation, inheritance, polymorphism, and abstraction. Another important feature of Java is that it does not support explicit pointers like C or C++. This design improves security and reduces the chances of memory-related errors. Instead, Java uses references and automatic memory management through garbage collection. Now, let's evaluate each option. Option A is platform independence. This is a well-known feature of Java, so this option is incorrect. Option B is object-oriented programming. Java is an object-oriented language, so this is also a feature. Option C is supports explicit pointers. This is not a feature of Java, because Java intentionally avoids explicit pointer manipulation to make programs safer and easier to manage. Option D is supports polymorphism. Polymorphism is one of the core principles of object-oriented programming, and Java fully supports it. Therefore, the correct answer is option C, supports explicit pointers. Let's select option C. Now, let's move on to question 8. The question asks, what is the primary purpose of the Java Virtual Machine, or JVM, in the Java programming language? To answer this question, let's first understand what the Java Virtual Machine does. When a Java program is compiled, the Java compiler, called javac, converts the source code into Java bytecode, which is stored in a .class file. This bytecode cannot run directly on the operating system. The Java Virtual Machine, or JVM, is responsible for reading this bytecode and converting it into machine code that the operating system can execute. Since every operating system has its own JVM implementation, the same Java program can run on Windows, Linux, and Mac OS without changing the source code. This is the reason Java is known as a platform-independent programming language. Now, let's evaluate each option. Option A is graphical user interface. This is incorrect because creating graphical interfaces is not the primary function of the JVM. Option B is platform independence. This is correct because the JVM enables the same Java bytecode to run on different operating systems, making Java platform independent. Option C is code debugging. This is incorrect because debugging is performed using development tools, not by the JVM itself. Option D is game engine. This is also incorrect because the JVM is responsible for executing Java bytecode, not for developing or running game engines. Therefore, the correct answer is option B, platform independence. Let's select option B. Now let's move on to question 9. The question asks, what is the output of the following Java program? To answer this question, let's carefully examine the code line by line. Inside the main method, an integer variable named x is declared and initialized with the value 5. In the next line, the statement x equals 2 plus 8 is executed. This statement assigns a new value to the variable x. First, the expression inside the parentheses is evaluated. 2 plus 8 equals 10. After the calculation is complete, the previous value of x, which was 5, is replaced with the new value 10. Finally, the statement system.out. println open parenthesis, x close, parenthesis semicolon prints the current value stored in the variable x. Now, let's evaluate each option. Option A is 50. This is incorrect because there is no multiplication taking place in the program. Option B is 10. This is correct because the value of x is updated from 5 to 10, and that updated value is printed. Option C is compiler error. This is incorrect because the program follows valid Java syntax and compiles successfully. Option D is 5. This is incorrect because the original value is overwritten before the print statement executes. Therefore, the correct answer is option B, 10. Let's select option B. Now, let's move on to the final question. The question asks, which of the following is true regarding how Java handles code execution? To answer this question, let's understand how Java executes a program. Java uses both a compiler and an interpreter during program execution. First, the Java compiler, called javac, compiles the source code written in a .java file into Java bytecode, which is stored in a .class file. Next, the Java virtual machine, or JVM, loads this bytecode. The JVM uses an interpreter, and in modern Java implementations it may also use just-in-time compilation to execute the bytecode efficiently on the operating system. This two-step process allows the same Java program to run on different platforms without changing the source code. That is why Java follows the principle of write once, run anywhere. Now, let's evaluate each option. Option A says Java uses only an interpreter. This is incorrect because Java first compiles the source code before execution. Option B says Java uses only a compiler. This is also incorrect because after compilation, the JVM is responsible for executing the bytecode. Option C says Java uses both an interpreter and a compiler. This is correct because Java first compiles the source code into bytecode, and then the JVM executes that bytecode. Option D says none of the above. This is incorrect because option C correctly describes Java's execution process. Therefore, the correct answer is option C. Java uses both an interpreter and a compiler. Let's select option C. That brings us to the end of Week 1 Assignment 1. I hope these explanations helped you understand the concepts behind each question, rather than simply memorizing the answers. If you found this video useful, don't forget to like, share, and subscribe for more Java programming tutorials and NPTEL course explanations. Thank you for watching, and I'll see you in the next video.